Okay, back to number 2. So we've looked at how we get our science. Now, we are actually talking about, first off, we're talking about the evidences of evolution. We're not talking about how it happens. We're not talking about why it happens or any of that. This is simply the evidences that we have that explain why the theory of evolution exists. So, this is the evidence that we have that has changed and is now changing. We're getting new evidence all the time that supports or discredits this. So that does not mean that we see how everything works out every time. We're simply talking about what we know currently. So the first evidence that we have that support the theory of evolution are fossils. Fossils are remains or traces of organisms that lived in the past. Obviously, we know that there are fossils around, especially out in Vernal. We have lots of fossils that have come from dinosaurs. So as we look, fossils are usually found in sedimentary rock. If that says usually, I don't know of a case where they're not found in sedimentary rock. Because if it's found in igneous rock, they would have been burned up. If it was metamorphic rock, the heat and pressure would have made them so you couldn't see them. They're always going to be found in sedimentary rock. So these are evidences of organisms that are buried soon after death, and the hard parts become fossilized. We can see that with the fossil record, fossils indicate a great deal about the actual structure of the organism and their environment. So we know how large they were, what they ate, how smart they were relatively based off of how big their brain cavity is. Evidences like that. So the first type of fossil that we see are petrified bones. These are the ones that most people think of when they think of fossils. What happens is, after they're buried, minerals actually replace the bones themselves. So this is not necessarily the bone, but minerals have come in there and filled up that space to where now it is extremely hard. It is essentially just rock at this point. Another one is an imprint. Imprints are going to be based off of the foot patterns or where an animal is laid, maybe a nest, these kind of things. Imprints into soft mud that dry up and then form a hard rock. Then we have molds and casts. Molds are going to be where an organism once was that now you essentially have a mold of it, kind of like an imprint, whereas a cast is where the rock around it has fossilized to where we now have pretty much a copy of what was there. We also have fossils that are preserved in tar, amber, or ice. All of these things are able to preserve fossils extremely well, and some of them we can see in more detail than others. Now, where they exist in the ground gives us an idea of how old they are. This is called relative dating. No, not the tab you on a prom, but how far it is in relation, how old it is in relation to other fossils. If it's down deeper, guess what? This one is older than this one. We don't know how much older. We don't know how old the organism actually was. All we know is relatively that this one here is going to be younger than this one. It's kind of like saying that you are younger than your parents and your parents are younger than your grandparents. That would be a relative age. Whereas if we wanted to get in more detail about that, you can see the layering here. Newer fossils are on top, older fossils are down lower. Sometimes things change, earthquakes can happen. A lot of times this is how things get set aside. You have your stream bringing in sediment. Your oldest fossils are down here. They've been layered down on over and over and over again. So obviously this one down here is going to be the oldest. We'll talk about radiometric dating on the next video.